welcome Nicholas, and I must say Nick from DAF Trucks. And I would say Tucson, Arizona, right?
Yes.
Yes, and that's not Hippie Highway here.
No.
You're going to peel the onions, as we speak in the Netherlands, on data, right?
Data science, how to get value.
Let's go, Nick.
Yeah, definitely. So thank you for that. Yes, I am Nick Vasilius. I'm from DAF Trucks, originally from Tucson, Arizona. I did not fly in today. I live in Eindhoven with my family. One of the questions I get, I'm the manager of data science and engineering for DAF Trucks. I've been working in data science and getting insights from data for the past 10 years for the parent company, PACCAR in the US. And one of the questions I always get is, how do we create value from data science? Now, just a quick survey. Who here feels like they're using machine learning, data science, AI? Just quick raise of hands. Who thinks they're doing it really, really well and always create value? All right, so we have a few really good practitioners. I'll have to follow up with you guys and make sure you agree with what I have. But this is an area that we have a lot of problems with. And I have identified a few key factors. So first, I work for a publicly traded company, so let me read a quick disclaimer. All the characters and examples in this presentation, even those based on real people, are fictional. All examples are purely demonstrative, and any resemblance or similarities to reality are purely accidental. This presentation and all contents therein are only opinions of the presenter and do not represent any other entities, including current, past, or future employers. Now I can speak a little more freely. So let's start off with some figures, right? 63% of survey respondents in a recent McKinsey poll report that they see revenue increases in business units that adopt AI. 57% of executives believe that AI will transform their companies within the next 3 years. 75% of organizations that are using AI are now shifting from piloting to productionizing artificial intelligence. However, shockingly, only 13% of data science projects succeed and make it to production. That means that in the data science field, 90% of projects fail. That's a really startling number. And there are a number of reasons I would say that we can attribute to it. One is academia teaches data science a perfect world where data always makes sense. Part of it is it's a new technology, and we're learning how to implement it and how to use it and things like that. But I've come up with 6 reasons why we don't get value from data science. So to start off with, for the multitaskers and the people who want to take a picture for their phone so that they can now multitask and do something else, here are the 6 reasons, right? I always appreciate it when someone does this for me, so I don't have to feverishly pull my phone out every 5 minutes. So we don't start with business value. We don't know the question. We think data science is normal from an IT perspective. We don't create a data science community. We fail to support the complexity. And finally, we don't ensure all elements are in place. And I'll go into a little bit more depth there. You need to understand I have a weird sense of humor, so some of this is going to be a little tongue-in-cheek as we go through it. So the first reason is we don't start with business value, right? We are blindfolded trying to find value. And oftentimes this is the way IT organizes data science, where there's a centralized data science team, and someone comes up with a cool idea, and then they develop a model, and then they find out the business doesn't need it, it's not actually something our customers want, et cetera. Who here has heard of South Park, the TV show? Yeah? There is an episode of South Park, which most people haven't seen, called the Underpants Gnomes. And we've all experienced this, where you wash your clothes and there's a sock missing or your underwear goes missing, et cetera. Well, the South Park gang notices this, and they uncover a massive global conspiracy of underpants gnomes. And these underpants gnomes have built tunnels that go into the back of every single washer and dryer globally, and they're stealing underpants. And of course, this leads to all sorts of shenanigans and over-the-top things. But as part of this episode, the underpants gnomes decide to, in a very James Bondy way, explain why they steal the underpants. And it's a 3-step process. Very easy to understand. First, phase 1, collect the underpants. Phase 2, phase 3, they make profit, right? And of course, there's a bit of back and forth that makes no sense. You can't just shrug when it's the middle part of your strategy. But they assure them, whatever the strategy will be, it will make profit. Unfortunately, I'd say 9 times out of 10, that's how we approach our data science projects, right? We approach our data science projects as, first we're going to take data, and then we're going to use AI, which, by the way, I hate the term AI personally, but we use AI, and we're going to create value, right? And we don't fill in that gap. And the biggest thing that you do is you don't start with understanding the business needs, right? You don't go out into your business, you don't go to your customers and find those pain points, right? But this is not only for data science, right? This is not only for machine learning models. In the 2020 SIM IT survey, the number 2 and number 3 concerns for CIOs. Number 2, alignment of IT with the business. Also, I don't like the business because it makes them something different from us. IT is part of the business, right? Otherwise, we'd be consultants. Not that there's anything wrong with that. But 35% of CIOs are concerned about that alignment. You know the number 3? Data analytics and data management, 25% of CIOs. So this is something that other CIOs are dealing with. And what I would recommend is send your data scientists out into the business. Place them as close as you can to the end user, the customer, the stakeholder, whatever it is, and make sure that they're getting those insights. Have them sit in the staff meeting. Let them hear the pain points and let them solve those problems, right? Number 2, and this is actually a common one, is we don't know the question, right? And that might seem like a weird thing to say, but data science oftentimes seems like magic, right? You pull out Siri or you watch, some big tech company share their new AI innovation on a World Cup advertisement, right? And it seems like they're magical. But really, in machine learning and data science, there's only 5 questions that we can answer, right? The 5 questions are yes or no. Which one is it? What category? Right? How much? What number? Right? Is this weird? By the way, I love this picture where it's just a donkey in the middle of a crowd. And then the final one is what's next? Right? And that might seem a little counterintuitive, but when we look at the statistical modeling behind the scenes, these are the only real 5 questions machine learning and data science can answer. Right? You can distill every single cool device, new initiative, down to these 5 questions. And if you can't, your project is going to fail. Period. Right? And so when someone comes to me and they say, I've got a great machine learning project, and I say, what is it? And they're like, we want to make sales better. I don't know what you mean in terms of the question. Now, part of a good data scientist is to sit down and help people frame that conversation, distill it down to what do you mean by better, right? We can take a page out of Six Sigma, the 5 whys, or the what's, the hows. Use your, who, what, when, where, why, how questions, and then distill down to, when you say better, do you mean you want better success when you approach a customer? Do you mean you want a more accurate pricing so that you're going to be able to compete with others? What do you mean by that? And distilling that down is going to help ensure your success. Reason number 3, we think data science is normal. Now, I'm sure everyone here has done their agile transformation and everyone is using Scrum and they are all very, very happy with story points and epics, and nobody's living in a waterfall world. I know that's true for PACCAR. But that's actually a problem for most data scientists. Because, and I can't say this enough, data science is not development. It's special. It's creative. Now, if you have to integrate it into your Scrum Agile practice, treat it more like a spike, a research spike, right? And time box it. But I've seen time and time again when you have a Scrum Master or a product owner trying to define the definition of done with a data scientist, and they say, what are you going to do this sprint? And they're like, well, I'm going to look at this data. And they say, okay, what are you going to do with it? And it's a little bit like the underpants gnomes. I don't know, I'm going to explore it. Okay, what do you think you're going to find? I don't know yet. It's more research and development. It's science. It's truly at its core a scientific process. If we knew the answer, we wouldn't need to have a data scientist look into it. And then you go into feature engineering, and then it comes to training the model, right? I need to optimize the model. Well, what are you going to do? Well, if I knew what I was going to do, I wouldn't have to run all these tests to optimize it, right? So that's one thing that I would recommend is try to, incorporate them into the Scrum process, hold them accountable, but don't treat them cookie cutter like how many lines of code are you going to produce. Reason number 4, we don't create a data science community, right? And this is really important. Now, you'll see online huge discussions about whether you should centralize your data scientists, decentralize your data scientists, or have some sort of hybrid. In case anyone's wondering, DAF has a hybrid strategy, hub and spoke. We have a core group in IT, but we also empower data scientists out in the community. And we also try to introduce better practices, new technologies, but we also execute on projects. So we use the hybrid one. That's not part of the conversation, but just so I save myself answering the question 100 times after the presentation, we use hybrid. But what I mean by that is the way we treat our data scientists does them a disservice, right? First, we put them into an ivory tower, right? Where they're off by themselves, they're special, they're unique, they're different. Now, I did just say that they are when it comes to Scrum, but making sure that they are a part of the conversation, making sure that they are in those conversations with the business, with customers and things like that are really valuable. Data scientists don't know your business, generally speaking. Data scientists, generally, don't know the technical environment that you're operating in. Only by working with others and sitting embedded in teams do they get those insights, and are they able to actually create the solutions you want. Second, data scientists love to explore, right? Most data scientists are the people who, when I was a kid, my grandmother had a percolator, right? Coffee pot, you heat it up at the bottom, water comes out of the top. My favorite toy when I was a child was taking that thing apart and putting it back together. Most data scientists have that same curiosity. They have that same, taking it apart, putting it back together, seeing if it will work. And a lot of people who work in the engineering space are like that too. Data scientists, though, also, nothing makes them happier than getting a new set of data and just finding something interesting, right? This is something that should be encouraged in your data science groups, right? I firmly believe in 20% time when it comes to the data scientists, because that 20% time where you cordon off, a day or certain afternoons, or you give them a little bit of a sabbatical so that they can go do something cool, you get really cool new insights and new technologies out of that. If we treat them and have them on the same sort of 2-week sprint schedule, it's going to dull them, and eventually you're going to have issues with retention. And then finally, data science is actually a team sport, right? The only thing better than having one data scientist is 2 data scientists talking about the same issue. Or having one data scientist or a small team of data scientists present to a larger community and having to argue and explain and talk about their findings and justifying them. Doing that will give you a much better rounded model and a better solution longer term. So, as you're talking about it, it's very easy in today's lean staffing to say we don't need a community. We don't need to pull these guys together. Why would I give, these people 20% of their time to just use, unproductively? And the reason is because it will pay off. It's an investment in them. Reason number 5, we fail to support the complexity, right? So, you remember this wonderful strategy we came up with where it's data, AI, and then value, right? And this is how I have seen innumerable slides that say basically this in different ways, right? What if I told you that that is a vast oversimplification? And even what I'm about to show you is a vast oversimplification. When we talk about data, we're talking about sourcing the data, storing the data. How do you select it? How do you share it? How do you consume it? Right? Once that data is in motion, it's been extracted into your data engineering platforms or systems, right? How are you transforming it? How can you enrich it? How do you make sure that you accurately attach, for example, we work in the trucking world, the configuration of a truck. That is actually a contentious issue that needs to be discussed. Are you talking about when it was built, as it's maintained, as we want it to be, as the customer would like it to be, things like that. And then how do you load it? Sometimes you're dealing with massive amounts of data. Data scientists, by the way, not data engineers, common misconception. Data scientists, even within data science, there's myriad facets, and here I have two of them. I have data analysis and I have machine learning, right? And in data analysis, you're exploring the data, you're starting to do hypothesis testing, you're cleaning it, you're normalizing it, you're doing feature engineering. In machine learning, you're selecting, training, testing, tuning models. And in between here, you also have deployment, right? We have the same DevOps issues that everyone else in the organization is having. And all of that is necessary for us to create value, right, of the selected model. And then we have constraints, right? On top of that, we have legal, privacy constraints. We have ethical restraints. I mean, there are, if you just look up AI ethics, there's a lot of different things that are coming up right now, and most recently, Facebook got in trouble for its advertising platform being used incorrectly and things like that. We have historical constraints. How long have you been storing the data? Is that a full business cycle? Do you delete your data because you have storage issues or data retention issues? That's going to affect what your data scientists can predict, right? We have security issues. How do you make sure the right people are accessing the right models, the right data? And then, as we all do, time and budget. Right? When you sit a data scientist down and you say, I want you to do this, and then you walk off, it takes a village to raise a data scientist, right? It takes a lot to do that. We don't oftentimes staff projects or teams that way. Oop, there we go. And then the final reason is we don't make sure we have all the key elements in place. And so this is kind of a summary of some of the other slides, but data science and machine learning can't happen in a vacuum, right? They're not magic. They're not wizards. Actually, that's funny. When I was a kid, people would ask me what I wanted to be when I grew up. And I told them the most sensible career choice possible. I wanted to be a wizard, right? Because I was really into fantasy, still am. And I grew up to be a data scientist. And there are moments where I do feel kind of like a wizard, right? I can take a block of undecipherable, honestly, most data is really garbage, but I take that and I come up with these amazing insights and models and actionable, we've created just an immense amount of value. I can't say dollar or euro figures, but let me just say it's a lot, right? And I feel that way, but it's not. It's hard work and it's making sure all the elements are there. Do we have the data? Do we have the technology? Right? If you give a data scientist a 5-year-old laptop, no access to open source code libraries and things like that, they're not going to be very successful. Identifying the customer, including internal customers. Most of my work is actually done for internal stakeholders, right? They're still a customer. Understanding the customer journey is important, even when we're talking about internal customers. And then finally, dedicating personnel. And it's important to make sure that you staff your teams appropriately or find a good staffing partner who can provide you high-quality data scientists, because I can tell you there's more finesse in that than you'd think. So, oh, come on. There we go. That's the end of my presentation. It was a very high-level one. I could talk for hours on this topic, but I really appreciate all of your time. Please do reach out to me on LinkedIn or afterwards, and thank you for your time.
Thanks, Nick.
Thank you.
So we are in a hype with data and massive data deployment. Everybody's talking about that, AI. Mm-hmm. So you explained a little where it goes wrong, so to speak, right?
Yep.
But without the fact that we will not go disappointed at home, what is good today?
I would say if you listen to some of those reasons that it goes wrong, and you take a good hard look and change the way that you're doing practices, or for the table here who have already done everything there and you've learned these lessons, the impact of machine learning and data science on an organization can be transformative. When I started at PACCAR in North America about 10 years ago, I started out as a spreadsheet jockey. I was manually cleaning data, uploading that to Access databases, exporting that back out to Excel and creating visualizations. And the timeline for our quarterly reporting was measured in weeks, let alone having anything more significant for insights. Right. Now we've shortened that down, and the value we can create is massive.
Right. So we are still good to go.
Yes.
We're still good.
Worth it.
Thank you, Nick. Thank you.
Thank you.